Hey guys, we are moving on to not quite a new unit. This is actually part of the quadratics unit, except it's not quadratics now. It's going to be exponential functions. So we're going to move on to exponential functions actually tomorrow. We are going to review a skill that we'll need to have down before we can do that tomorrow. So today we are going to review negative exponent rules and also the briefly the anything to a zero power rule, which anything to a zero power is 1. Okay. So tomorrow, because we're doing exponential functions, we will have to be raising numbers to exponents, both negative and positive. We did the negative exponent review, if you recall, earlier in this semester. So we will go ahead and review that because you may or may not remember that very well. Plus, we're going to learn how to raise fractions to a negative exponent, which I don't recall that we actually did. I think we just did whole numbers, okay? So this is slightly in a different context than what we were doing before, which is we were dealing with polynomials. Okay, so the rule is any number a raised to the negative exponent, or negative n, equals 1 over a to the n, or that number 2 raised to that power. So basically what a negative exponent does is it makes a fraction, okay? So basically you just put 1 over whatever that number is raised to that power, okay? And also I have down here just to add, and this is the zero power rule, anything to the zero power equals 1, okay? You'll have to remember that. But that one's not hard, okay? So say for instance we have 4 to the negative 1 power, okay? All we do is we follow the rule. If it's 4 to the negative 1, it then becomes 1 over 4 to the first power. And 4 to the first power is just 4. So the answer is just 1/4. Okay? Now let's say we have 4 to the negative 2 power. Okay? 4 to the negative 2. Again, oops, I didn't put my line there. There we go. We have 1 that changes to 1 over 4 squared. I guess it's negative squared. And then 4 squared means 4 times 4, right? So we'll have 1 over 4 times 4. Let's do that. 4 times 4, which is 16, and that's the answer. Okay? Now, let's say we have, number 3 will be 4 to the negative 3 power. Okay? That will then be, dang it, I forgot it again. Oh, there we go. Okay, 1 over, there's my fraction bar this time, 4 to the 3rd power. Okay? Which will then be 4 times 4 times 4. 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So the answer there is 1 over the 64. I'm sorry, 1 over 64. I don't know what I'm saying. That's the answer, 1 over 64. So 4 to the negative 3rd power equals 1 over 64. And you can go onward like 4 to the negative 4th power, 4 to the negative 5th power, etc. Okay, we'll stop there with this though. Okay. Now, one thing you didn't learn, at least I don't think you learned, was taking a fraction to a negative power, okay? Now, we have to remember our fraction rules, and that's another thing I'm going to review here, okay? Specifically dividing fractions. So I'm going to draw a line here. So number 4, this fraction. Say I had 1/2 to the negative 1 power, okay? What I again do is this. I just put it under 1. 1 over 1/2 to the 1st power. Okay? Now, what this is saying is, because you remember the fraction bar is also a division bar. Another way to read this is 1 divided by 1/2. I'm going to rewrite that horizontal instead of vertical so we can simplify it. Okay? Now, I may have skipped this. Any number to the 1st power is just that number. So I will then have 1 divided by 1/2. Okay? Now, our fraction rule, dividing a fraction, it is keep, change, flip. We keep the first number the same. We change the division to multiplication, and we flip the fraction to its reciprocal. Okay? That's dividing fractions, which you've been doing for years now. Okay? So, I'm going to keep the first number, so I'll have, let's do this, equals 1. I change this to multiplication, and I flip this to 2 over 1. Now, 1 times 2 over 1 is just 1 times 2, because any whole number over 1 is just that whole number, right? So 1 times 2 over 1 equals 2. So the answer then is 2. So 1/2 to the negative first power, or negative 1 power, is going to be 2, right? Now, to think about this logically, if I take 1 divided by 1/2, how many times does 1/2 go into 1? Well, it goes into 1 2 times, because you have to have 2 halves to make a whole. So logically, when I say it that way, it makes sense too. Okay? Let's move on to a slightly bigger number. Say I had, not actually a smaller number, because the exponent's getting bigger into the negatives. So then say I had 1/2. Let's do to the negative 3. Okay? So, let me draw a line here. Okay. 1/2 to the negative 3. All right? What that would be then, I'm going to move down here actually, it's going to be 1 over, okay, 1 over 1/2 to the third power. Okay? Now, 1/2 to the third power is going to be 1/2 times 1/2 times 1/2, right? Well, 1/2 times 1/2 times 1/2, okay? And here again, we have to use our fraction rules. If I can let me write that a little bit better. 1/2 times 1/2 times 1/2, okay? So when you're multiplying fractions, this again is a review, you multiply your numerators all together and your denominators all together. So I have 1 times 1 times 1 equals 1. Then 2 times 2 times 2 equals 8. Okay? So, that being said, I then have 1, this equals 1 over 1/8. Okay? Now, again, I'm going to change that from a vertical division problem to a horizontal one, just because I think it makes a little bit more sense visually. So then I have 1 divided by 1/8. Make that a little bit more clear to see, okay? Then I use my fraction rule, keep, change, flip. And so, I'll actually draw a line here. I then have 1 times 8 over 1, which equals 8. Okay? I kept the first number, I changed the division to multiplication, and I flipped my 1/8 to its reciprocal, which is 8, and 8 over 1 is just 8. 8 times 1 is 8. Okay? So if you notice a pattern here, if I have a fraction and my exponent gets smaller, meaning it's going into the negatives more, that means that my answer is actually bigger. So like 1/2 to the negative 1 power is 2, whereas 1/2 to the negative 3 power is 8. Okay? Now on the opposite side, if I have whole numbers, as the number decreases, which it actually is decreasing because you're going into the negatives, it's not increasing. As the number decreases, your answer gets smaller as well. Okay, so today's practice is just going to be this, okay? You're just going to do computation basically with exponents. Then tomorrow we will move on to exponential functions, where you'll be required to use this skill to create values for a table of values and then graph it. Okay? That's all for today.